Hello, math humans. We are going to do 1.7a today. We're going to start our discussion on transformations. Today, specifically, we're going to focus on horizontal and vertical translations and horizontal and vertical reflections. So the first thing that I want to do is talk about a definition that you got way back in geometry, and it's called a rigid transformation. So a rigid transformation is one where the size of an object stays the same. It might change orientation, it might change location, but it's not going to change size. Then a non-rigid transformation, that's a long word, is going to be one where the size changes, okay? All right, and I'm a little bit lazy, so I like to write change with a triangle. All right, so as we start, we're going to talk about a translation. And a translation is a change in location. All right, and for us, that's going to mean it's either going to slide to the left or to the right, or it's going to slide up and down. So in all of these discussions, we want to talk about what I call, and so it may not be technically correct, what's considered outside the function, and then what's inside the function. And I'll explain that as we go along, but outside the function is always going to be a horizontal, I said that wrong, it's going to be a vertical change, and something that's inside the function is going to be a horizontal change. I had to think about the equations that I'm about to write. All right, so as we have these discussions, just for purposes of clarity, f of x is going to equal the original function, and then g of x is going to equal the changed function, okay? All right, so if I had something that said g of x is equal to f of x plus c, so this would be what I was talking about. This is what I would call outside the function. It's not inside the parentheses. So this is going to be a vertical, because it's outside the function, shift, and then it's going to either, I'm going to change that to a plus or minus, it's going to either go up C or down C. If it's up, C is positive. If it's down, C is negative. So it's really pretty straightforward. On the other hand, if I had something that said g of x is going to be f of x plus c, notice the difference. Notice now that the c is inside the function, okay? So this would be a horizontal change, and this is going to be a horizontal shift to the left. So this is one of the things that's also fairly tricky when we start talking about inside and outside. Whatever is outside the function is going to have the sign that's listed. Anything that's on the inside of the function is always going to be either the opposite sign or it's going to be the reciprocal of the value inside. And I'll explain that more as we go along. Today, we're just going to be talking about the opposite sign. Alrighty? So I think, let me just write one more example. So g of x is f of x minus c. Again, notice that this is on the inside of the function. Therefore, this is a horizontal change. And this would be a horizontal shift to the right. Oops, I forgot the T. To the right. Notice that it's going to be x minus the value of c. That's going to be the standard notation. So minus a minus is going to give us a plus, which is why this is going to the left. And minus a positive would be the shift to the right. Okay? All right, so that's our first round of translations. So now let's talk about transformations, or other transformations, I guess I should say. So in these transformations, we are going to have a change in orientation, and that's going to primarily be, for today, that's going to be a reflection, okay? So if I had g of x, remember g of x is the one that's been changed, a negative f of x, this is outside the function. So remember, outside the function is a vertical change. This is a reflection across the x-axis, okay? And if you think about, if you can visualize in your head, if I have something here and I make it negative and then it's going to reflect across this axis, it is a vertical change. On the other hand, if I have g of x is equal to f of a negative x, notice this is inside the function, which means it's going to be a horizontal change. So this is going to be a reflection across the y-axis. And if I stick with my same little example, okay, so if I start with something here, and I reflect it across the y-axis, it's going to go over there, and this is the horizontal change. So that's how I remember these. I remember that if something is outside the function, it's a vertical change. If something is inside the function, it is a horizontal change. All right, my light seems to be really shadowy today. Sorry about that. So let's do our first example. We have a nice short video today, by the way. So my parent function is going to be y is equal to the square root of x. And then in all of these examples, I want to describe the transformation. Okay. All right, and then we're also going to sketch them just because sometimes a visual is really nice. So in the first example, my new equation is going to be g is equal to, I guess I should say g of x is equal to the square root of x minus 3. Okay, so before we actually start doing the transformations, let's talk about the sketch of the parent. Remember that this is the square root function, and it's just the positive portion of the curve because it just makes our translations a little bit easier if we just focus on the principal root. This is outside the function. It's a vertical change, so this is going to go down 3. And so that means that if this was the standard graph, when I translate it, it would go down 3, and so it would look like that. So that's not so difficult. All right, next example, example 2, we're going to change our equation a little bit again. So this time I'm going to have y is equal to a negative x. So notice that this is outside the function. Again, it is a vertical change, so this is going to reflect across the x-axis. And if we talk about the graph, let me get my original color. If this was the original function that goes this way, then the new one is going to be down here. So that is a reflection across the x-axis. All right, example 3. These are really pretty quick examples. So what if I had g of x is equal to x minus 4? This is inside the function. It is a horizontal change, so that means it's the opposite sign. So this is going to move 4 units left. Okay? And so if we had our graph, what color did I use? Purple. If this was the original function, now I'm going to move 4 units to the, bad. Shame, shame, shame. This is to the right because it's the opposite sign, sad day. So then this would be 4 units, and then it would be to the right. Whew, glad I caught that. All right, let's do our next example. So that was 3. This is going to be example 4. Okay, and in example 4, now we're going to start bringing in multiple equations. So what if I said g of x is equal to a negative x plus 3 plus 5? Here is a huge word of caution. Anytime things are on the inside of the function, your job is to factor first. Factoring is our favorite F word. Ooh, look, we got 2 F words in there. But if you don't factor, you will misrepresent what's going on inside the function. So this is, I'm going to factor out a negative 1, and I get x minus 3, and then the 5 just stays outside. So when I talk about multiple transformations within the same function, I always report math left to right. So this is going to be a reflection across, remember it's inside the function, so it's a horizontal change, so across the y-axis, it's going to go 3 units to the right, and then it's going to go up 5. So on a test, if you don't report in the correct order, then I have to take off points, and that's a sad day. All right, next example, and actually it's our last example. So this time I'm going to say g of x is equal to a negative, and then I'm going to change this one. Actually, no, I'm not. We'll do that in our next video. Here, outside the function, vertical change. So this is a reflection across, I forgot to sketch it, the y-axis, x-axis. Can't get my brain to think multiple things at the same time. That's an x in case you can't read my scribbling. Then I'm going to go 4 units to the left, and I'm going to go down 3. Alrighty, so as we keep talking about transformations, the insides of the function will get more complicated, and as they do, you really have to make sure that you factor first. All right, my dears, that is it for today. I will see you soon.